You lived through years of your own life that you have zero access to. You were born. You opened your eyes for the first time and saw shapes and light you had no words for. You heard a voice that would eventually come to mean mother, long before you understood that sound could mean anything at all. You tasted food for the first time. Someone caught you the first time your legs gave out mid-step. You said your first word and somebody in the room almost certainly cried. And none of it exists for you. Not one frame. Not one sound. Not one flicker of light through a window. Ask most people why and they'll give you the same tidy answer. Your brain just wasn't ready yet. You were too young to remember anything. That answer feels right. It also happens to be almost completely wrong. Because your infant brain wasn't failing to record your life. It was recording everything constantly in extraordinary detail. Your memories were there. Something came along afterward and destroyed them. In 1905, Sigmund Freud became the first person to put a formal name to this phenomenon. Called it infantile amnesia. For decades, that's mostly all it was, a label for something nobody could fully explain. Here's the first thing we actually know for certain: babies can form memories. That part isn't in question. In the 1980s, a psychologist named Rovee-Collier at Rutgers University ran a small experiment that quietly reshaped the entire conversation. She tied a ribbon from a baby's ankle to a mobile hanging above their crib. Within minutes, the babies figured out that kicking their leg made the mobile swing and spin. And they loved it, kicking again and again just to watch it move. Then she did something clever. She brought those same babies back days later. Same crib. Same mobile. No reminder, no demonstration. They remembered instantly. They started kicking the moment they were placed back in the crib, as if no time had passed at all. Even 2-month-olds could hold on to that memory for a couple of days. 6-month-olds carried it for weeks. So infant brains can absolutely learn. They can store information. They can pull it back out later when it's useful. But those same memories don't last into adulthood. By the time you're old enough to ask this question, every trace of them is gone. And for decades, scientists couldn't fully explain why a brain capable of forming a memory couldn't also hang on to it. The first part of the answer is structural, and it starts with a small curved structure buried deep in your brain called the hippocampus. Think of the hippocampus as the part of your brain that takes a moment you're living through and files it away as a story you can replay later: a birthday, an argument, the specific smell of a childhood kitchen. In adults, the hippocampus works closely with the prefrontal cortex to tag these episodes, store them, and pull them back out on demand. But in an infant, that entire system is still under construction. The wiring between the hippocampus and the rest of the brain is incomplete, patchy, still being laid down piece by piece. One key structure inside it, the dentate gyrus, which acts almost like a gate that new memories have to pass through, doesn't finish wiring itself until somewhere between the ages of 2 and 4. So your infant brain could grab onto short bursts of memory, the way those babies remembered the mobile for a few days. Just couldn't file anything away for the long haul. That's the textbook explanation. And for a long time, that's where the story stopped. Except in 2014, 2 neuroscientists working out of a children's hospital in Toronto asked a question that sounded almost backwards. Sheena Jocelyn and Paul Franklin wondered, what if the exact same process that's busy building your brain is also the thing quietly tearing your memories apart? Here's what they meant. In the first years of life, your hippocampus is manufacturing brand new brain cells at a staggering rate. This process is called neurogenesis, and it's completely essential. It's how your brain wires up the circuitry you'll rely on for the rest of your life. But new brain cells don't appear quietly off to the side. Every time a fresh neuron wedges itself into an existing circuit, it disturbs whatever was already wired into that exact space, including, potentially, whatever memory happened to be living there. To test this idea, Jocelyn and Franklin ran the experiment on mice. When they artificially sped up neurogenesis in adult mice, those mice started losing memories they'd already locked in weeks earlier. When they slowed neurogenesis down in infant mice, the opposite happened. Those baby mice held on to memories for far longer than they normally would have. The conclusion, published in one of the most respected scientific journals in the world, flipped the whole story on its head. Your baby brain wasn't too weak to hold on to memories. It was too busy constructing itself to leave them standing. The same flood of new neurons that built the very brain you're using right now to follow this sentence is the same flood that overwrote almost everything that came before it. Your earliest years weren't lost because they were never recorded in the first place. They were lost because your brain kept knocking down walls to build new rooms, and your earliest memories happened to be standing in one of those rooms when the wall came down. But even that isn't the strangest part of this. There's another layer underneath it. To form what scientists call an autobiographical memory, the kind where you're the main character reliving something that happened specifically to you, you need one thing that's incredibly easy to take for granted. You need a you to attach the memory to. You need to already understand that you exist as a separate person, that things are happening to you specifically and not simply happening somewhere out there in the world in general. According to developmental psychologists who studied this closely in the late 1990s, babies don't actually have that yet. Not for a while. There's a classic test for this, and it's almost embarrassingly simple. Put a small dot on a baby's face without them noticing, and sit them down in front of a mirror. Before around 18 months old, the baby looks at the mark in the mirror and doesn't touch their own face at all. To them, that's just some other kid staring back with a mark on their face. After 18 months, something flips. The baby sees the mark in the mirror and reaches straight up to touch their own face. They understand, maybe for the first time ever, that the person staring back at them is them. And that moment lines up almost exactly with the earliest point at which autobiographical memories are even capable of forming in the first place. Which means part of the reason you can't remember being a baby is unsettling in a very different way than the neuron explanation. It's not just that the memory got physically erased. It's that there was no continuous you yet to own the memory in the first place. No narrator quietly running in the background of your mind, stitching individual moments into a story that belonged to someone called you. Which brings up a strange question worth sitting with. If there was no steady sense of self back then, and the brain that held those first experiences has since been physically rebuilt almost beyond recognition, is the baby in your old home videos actually you? Or is it someone else, someone who happened to live in the body you're using right now before that body's mind was quietly dismantled and reassembled into the person currently watching this? There's one more piece to all of this, and it might explain something you've never actually noticed before. Language. A developmental psychologist who spent years studying how children form lasting memories found something genuinely surprising. Language doesn't just describe your memories after the fact. It's what gives them a shape sturdy enough to actually survive. Before you could talk, your experiences existed as raw, unlabeled sensation, light, sound, texture, emotion, all real, all happening, all without any container to hold them together afterward. Once a child starts talking, and especially once the adults around them start narrating the child's own life back to them, remember when we went to the park? Remember when the dog surprised you? Something shifts almost immediately. Their ability to hold on to memories for the long term jumps dramatically. Language gives a memory a skeleton to hang on to. Without it, an experience is like water poured onto sand. It's there briefly, and then it's simply gone. And here's the part that proves this isn't just an abstract theory. A psychologist at Cornell found that the age of a person's earliest memory actually shifts depending on the culture they happen to grow up in. In Western households where parents constantly narrate a child's day back to them, asking questions, retelling stories, building a personal narrative out of ordinary moments, people's earliest memories tend to reach back to around age 3.5. Among the Maori of New Zealand, where oral storytelling and personal history are treated as central to identity from early childhood onward, average first memories reach back even further, closer to age 2.5. In some East Asian cultures, where early narration tends to focus less on the individual child's personal story, first memories tend to start later, closer to age 4. Same species. Same biology. A different depth of memory based almost entirely on how much your culture talked you into existing as a character in your own story. So here's what actually happened during those years you can't get back. Your hippocampus wasn't finished being built. And even in the moments it was working, a flood of brand new neurons was actively overriding the space where those memories lived. You didn't yet have a stable sense of you to attach the experience to. And you didn't have language yet to give the experience a shape sturdy enough to survive. It wasn't one clean explanation. It was all of it, happening at once, stacked directly on top of each other. Every single person who has ever lived went through this exact same blackout. Every person you've ever loved has a hole where their first years should be. And the honest answer for why isn't that your brain was too underdeveloped to bother remembering. It's that your brain was busy doing something far more demanding than remembering anything at all. It was building the person capable of remembering in the first place. And that meant quietly, necessarily taking apart the one who came before.